What I hope to be one day restoration. What we have in front of you here is this, a Heathkit AF-1 Audio Frequency meter. It's kind of the, well, it's audio frequency only, but it really is the predecessor to something like that up there, which is my Hewlett-Packard Western Electric frequency counter. I got this the other day and was able to go online and look up some information about it, not a whole lot. Now this, I've already taken the cabinet off, and right now I'm just going to do a basic overview and do a few tests. So this is it. You have your input here, you can select your frequency range, and it goes all the way to 100 kilohertz. So it goes, 0 to 100 all the way up to 100 kilohertz, and then you just use this range here. And pretty basic controls, off, on. If we turn it around, what we have here is the meter movement and power transformer, 665 rectifier, a capacitor, filter cap, the 686 tube. This is the VR150 regulator. I think this is the 6SJ7. Oh, this is the 6V6, which is kind of like the driver. This is the, and this is 6SJ7, which is the input. If we look underneath of it, it's fairly clean, and it doesn't look like it's been messed with much. We have a few of these 0.1 microfarad mica mold caps, which mica mold was just a brand. These are just standard paper caps, just wrapped in a plastic case. Got a couple other caps here. Here's the band switch, and it goes to these potentiometers for adjustment of the frequency of the setup and the alignment. One power resistor, a couple other larger resistors, but you can tell this is a kit, and there's a couple ways you can. If you look right here, that wire's just looped over, it's not even soldered. But the first thing I want to do is test the meter here. I'm going to do this the way I tested the meter in my ICO. And that is to come with my digital multimeter, my fluke here, and turn it on. And set it to manual. And put it on kilo ohms because I don't want to put too much voltage into this. And we'll see if we get any continuity. Yes, we get continuity. And meter deflected because since it's a resistance measurement, the multimeter's putting some current into it. And I'll bet you if I hit this, yeah, if I put it on ohms, I get a lot more deflection because it's putting more current into it. So yeah, it's working, which is good. I'll start tearing into it. And it has a pretty basic circuit. I do have the schematic here, which is able to get online. And I'm going to pull the rectifier tube and measure the voltages here to see what kind of voltage I get on here. And to see if the transformer's any good, I'm going to do those basic tests first before I do anything else. So I'll pause it here while I hook a few things up. Alright, I have it hooked up. The meters hooked up to the output of the transformer. And okay, transformer put out voltage, 502 volts. Start with that, and let's start desoldering parts and fixing cold solder joints and all that good stuff, and then we'll fire it up. I do have a audio oscillator that I can test with it, and I can check the accuracy of this unit here with my scope, which does measure frequency. And of course I've also got an app. Now, you say you've got an app for it. Yeah, I've got an app on this that is an audio oscillator. I'd rather not plug that into something that I don't know if there's any voltage on the terminals or not. But I can use my tech scope over there to measure any frequency that I set up, and I have a Motorola frequency audio oscillator to get everything all set up. Alright, this is about what I was able to get done today. It's not going to all be done today, but almost got completely done. Have replaced most of the caps. Only have one of the 0.1s left, and then one of these, the 0.01, and then the filter, which I'm going to mount on some terminal strips. And you know, it's looking pretty good. I'm using these little yellow jobs, but they're all higher precision than anything that was in here before, because if you look, I don't know if you can see that on there, if it's gonna focus. Are we gonna focus? Yes, no, maybe not. Yeah. But on the micromold caps, they're all 20%. In fact, all these caps in here are 20% tolerance. And so I figure I'd just replace them and get them in there. I did save the leads on these. You know, left them longer. I have half a mind to just throw them on eBay for the audio fools, the audiophile people to snap up, because they seem to love them and they seem to think that you need to leave them in the circuit. And in fact, I saw a great argument on Audio Karma where someone said you need to leave those caps in there. If you take them out and change them, it changes the characteristic of the amp. And that's true, it does change the characteristic of the amp and makes it work. Because by this time, all these caps are old, leaky, they don't work. So I don't understand that, but whatever. So I'm going to call this done for today. Pick up on it again after the new year. I'm going to the gym to get my last lift of the year in, and I'll pick up on it later. Today is New Year's Day, and I'm working on this again. I've got most of the capacitors. I still got a couple I've got to replace. And then what I'm going to do is I'm spot checking resistors. And there's two here in the power supply right here. They're supposed to be 470 ohms, and not even close. 585 is that one, and the other one measures about 570. So they're both off enough that I'm going to replace them. And I have these Panasonic 2-watt metal film, so 5% tolerance resistors. So I measure one of those, you know, it's 470 ohm. And I get 469, so that works. You know, so that's going to go in there, and what I'm actually going to do is, you know, they go right here, so I'm going to put them in and I'll spot check some of these other resistors. I've already replaced the 1 meg that was actually not, it measured okay, but it actually crumbled apart. So some of these early to mid 50s electronics, the components weren't the best because of the Korean War and just coming out of World War II and then the Korean War, so the component quality wasn't the best. But I'm going to continue to work on it, and then I'm going to try to fire it up. Alright, got all the capacitors replaced a few resistors, as you can see here. There's the old capacitors. There's a couple of resistors laying there too. But I'm about ready to repopulate the tubes and try and fire it up. Also replace the 47 pilot light, which was missing. Get it all buttoned up before I head off to the gym again. And since this is the first time I'm going to be turning this on, I'm going to do my normal Variac power up with the dim bulb tester, just to make sure I did not do something really dumb. Good. Getting pilot light glow. I should be getting pilot light glow. Okay, I'm starting to see tube filaments glowing. It's kind of hard since one is filthy dirty. The rectifier I can see, and the voltage regulator doesn't. So no pops, no dull glow on the bulb here. You can just barely see it. And I'm at 110 volts. I'm going to stop this for the moment, head to the gym. I'm going to turn this off, and when I come back I'm going to hook it up to the audio oscillator and the audio oscillator the scope to make sure that I get what I'm supposed to. What you see here is my test setup for the audio frequency meter, and what I've got here is my Motorola audio oscillator and then the frequency meter, and it is also hooked up to my scope, which is going to be hard to see from here, but so I've got it all set up. I've got it on 50 Hertz. It is a bit off, so I have to flip this around to see where the adjustments are for it, because it is actually written here. So they're all labeled right here. Hard to see with the power transformer in the way, but they are all labeled, kind of. And get my little screwdriver here. And same thing on the 300. This will be off by a little, because all the original components were kind of out of whack, and it's sat for a while, but it is working, so I'm going to finish calibrating it.